Today, we're going to be talking about modernizing water infrastructure with performance contracting or solutions for the water energy nexus. Next slide. So it's relatively obvious to most people, right, that there's a huge connection between water and energy, right? The two most important things that we need to live in today's life, right? I was at a university last week back in DC speaking to a bunch of students about getting into the energy industry, and a woman I know from one of the ESCOs we work with said, if it wasn't for electricity, none of you would be able to do anything today, right? Everything in your life as somebody in their teens or 20s revolves around electricity, right? Literally every single thing. So we become very, very dependent on it. And of course, we all need water, right? Whether it's drinking water, take showers, make your coffee, cold beer, hot showers, the whole thing. And it's becoming a bigger and bigger issue as time goes on. So we're going to talk about how they are linked, how ESPC can address this nexus, and all kinds of different projects and measures that can be used. We're going to cite some actual case studies, a few that I've worked on and others. And then Jamie's going to go through a campaign wrap up. Next slide. So today, this is a webinar format, so drop your questions in the Q&A box. And as we get to the end, we'll take people's questions. We're going to be doing a recording of this, and anyone that registered for this, so if you have folks that registered and weren't able to make it, they will get an email with links to both the recording and the slide deck. And we're only going to record up until the end of the presentation. Then once we get to like a Q&A and all that, we won't record that. So we don't want people having to have their questions answered online forever. Next slide. All right, introductions. So there's me, Chris Alp, and I've been sort of the main talking head here for the past 2 years doing these presentations. But meanwhile, Jamie has been the wizard behind the curtain for me, really providing all kinds of strategy and content and fixing my engineer's attempt at artwork over the past 2 years, and I'm eternally grateful for all the help she's given me. And I'll let her give her own introduction here in a minute, but she's principal and founder of Trellis Strategy and has been in the business here for many years. Next slide. So again, I'm not going to go into a lot of this. I've been at this for 40 years. Actually, this month, that's 41 years I've been in the industry. Graduated with a mechanical engineering degree in '85. I had my own owner's rep firm doing energy consulting for many years. Sold it about 7 years ago, and now I'm working part-time. Moved out west here about 8 years ago, and look forward to continuing with anyone who wants to know more about ESPC after this. And Jamie, as I said, has been at this a while as well. She's founder and owner of Trellis Strategy. She helps large and small companies, nonprofits, advance their investment in energy efficiency and infrastructure modernization. Fantastic background and strategy, and really helping people get their messaging out, which is huge. Next slide. So ESC has been around for almost 30 years. I think it started in around 2000, 2002. I have to attribute a lot of this to my friend Linda Smith, who was the energy czarina in Colorado for many, many years. She's now retired in Santa Fe, New Mexico. But her and a few other state energy officials in the Mountain West started ESC many, many years ago. And unfortunately, we're going to be dissolving ESC here in a few months. But it's been a great organization for many years and has helped me when I was doing this full-time as an owner's rep with the model documents and everything they put out, and really teaching state energy officials and local school districts and governments all about performance contracting. Next slide. So performance contracting is, as I like to say, it's a financial mechanism used to pay for today's facility upgrades with tomorrow's energy savings without tapping into your increasingly precious, right, organization's capital budget. And if done properly, and this is a tagline I borrowed from an old EPA ad for Energy Star, it has the performance of a hedge fund with the risk of a T-bill. Right? Even today, done properly, right? With, good model documents, using an owner's rep, um, hiring a partner in an ESCO. You really work these out so that you get a really well-performing project with very little chance of failure, with a very reduced level of risk, right? So it's, again, done well. It's following all the best practices we've been teaching here for the past 2 years. Very few of these fail, done that way. And DOE got into this in the mid 90s after EPAC 92, and they put this a bit more formal definition of it. And really, what it comes down to is a version of design build contracting with a focus on guaranteed energy savings. And for people in the public sphere, it's so much different and so much better than design bid build, right? For many reasons we've gone into in many different times during these presentations. Next slide. So what this really comes down to is a budget cost neutral delivery vehicle. So it's a financing vehicle to do technical work for the, and in this case, that these webinars are aimed at the MUSH market, but this has gotten done in the federal market for about 30 years now. It really started in the MUSH market in a few states, Ohio and Washington State and a few others back in the late 70s and 80s. But it allows you to take your existing operations and maintenance budget, right? You and your ESCO identify savings. Usually it's 20 to 30, 35% savings on your utilities, operations and maintenance costs, and so on, always delivering a small net positive cash flow every year of the contract term, right? That's usually in state statute, no matter where you go, right? And then that money that you used to use to pay all your utilities and contractors that were taking care of 40-year-old equipment, you can then fence that money, if you will, and move it from pay the utility and contractors line items in your budget over to pay back the bank line item in your budget. So it allows you to monetize what would usually be a capital cost, right? You're basically taking an annualized operational cost and making it into a capital investment in your own facilities instead of just handing it to a utility every month, which is continuing to increase, right? Every month. And look at what's going on now, right? With the war in Iran, utility costs are going to continue to increase and all these different things with data centers and all that. So throughout the contract term, as you're paying off this loan, you always get this net positive cash flow. And at the end, but 15, 20 years, then you get to recoup all those savings. Next slide. So this has been going on a long time, like I said. It really was trying to help public agencies, like after the last oil shocks, right? In the 70s with the oil embargo and all from OPEC, it really was a trying time for public institutions in this country, right? Schools and hospitals especially. And when I got into this industry in 85, the Schools and Hospitals program, the Institutional Conservation Program, was really doing a lot of great things for these institutions. But it was all design, bid, build, right? And I saw clients who would get 50% of the energy audits paid for by the Department of Energy, 50% of the ECMs, the measures paid for, right, in cash by the government, still couldn't go forward because they couldn't come up with the rest of the cash. So performance contracting filled that void, right? You avoided the long procurement cycles, 5 to 7 years. You get done in 2 years. Very strict budgeting. Like I said, if you did a lighting project yourself, the budget people rewarded you by cutting your energy budget the next year, right? You didn't get to invest that money anywhere, or you didn't have money that you could then use to do more projects. And most public agencies are very conservative, as they should be, right? And are very risk averse, as they should be, right? But this really hit all those check boxes for a lot of different agencies to be able to use a different way to procure solutions for the facilities. And there's all these benefits. So we talked about these in every single webinar that we've done. I won't go into them in detail. One of the things, or a few of the things I think are the most important these days, as the economy starts to slow down here in the US, is job creation, right? And this was huge during the Great Recession right here 10, 15 years ago. It created hundreds of thousands of jobs around the country at a time where the unemployment rate was, 5 to 7%. And giving these public institutions guaranteed results, which they never get, right? Whether it's building a new wing onto the hospital or renovating a school or building a new fire department or library. Most public agencies have no recourse when it comes to a project that gets completed and it doesn't meet the requirements, right? It just, they have very little they can do. With performance contracting, it allows them to work together with the ESCO as a partner. And at the end, all parties have an investment in this being a success, right? So and guaranteed results is one of the reasons why. And resilience, I think, is one of the single most important things that much market folks can use performance contracting for, because there's no right monetary value. There's no market for resilience, right? There's no trading like carbon markets and nuts and stocks markets. There's values to that, but there's no value to resilience yet, right? Um, but being able to use performance contracting to, put generators or solar and battery storage into schools that are designated places of refuge during storms, that is huge, right? And it's very hard to do it otherwise. Next slide. So it's not only good for resilience, but it's been a resilient model over time, right? Through every administration, right? I've been working in performance contracting since 1996, right? This is 30 years this year in it. And I've seen it across 6 administrations, federal administrations, multiple changes in governors and state legislatures, and it works no matter what. Whether it's in a time a few years ago where there was a lot of federal money coming into the market, or what it was like right before that, there was no money coming into the market because the economy was slow. And here we are today, where a lot of that federal money is going away. Performance contracting is still here. Getting that extra money, for me, it's like gravy. It makes the projects better. It allows measures that might fall off, like doing boiler replacements and battery storage. But lighting controls, water conservation, all these things, all are still financeable. And interest rates today, although people complain about the mortgages being high, 5 and 6% is a bargain historically. I can't tell you what I spent on my first car at college in 1985. Painful to think back about that. But this has been able to change over time as business and industry have changed, and trends have come and gone. But it's always had bipartisan appeal, right? For me, it's a purple issue, right? It's not red, it's not blue. It creates jobs, right? It allows reinvestment in local economies and local communities. And it also saves energy, saves carbon, addresses climate change, right? Anything that anybody wants to know about this, it works for, really conservative rural communities and really progressive urban communities and everything in between. Um, Another thing that Congress has been all over this, right? The federal government has been doing this, like I said, since the mid 90s. The US military is, very quietly the largest user of this in the world, right? And they know how much it helps them meet their mission requirements. One of the reasons it has bipartisan appeal is because the transparency that's created by rigorous measurement verification that you don't get anywhere else in any government funded or privately funded investment. It's just not there, right? Having something that everyone can agree on and how we're going to create a success metric that's measurable, right? And all parties can understand it. It's very, very hard otherwise to do that in construction anywhere. Next slide. All right.
All
We're going to
right.
turn this
So,
over to
yeah,
Jamie. There you go.
I wanted to tell you all a story about how I got into this energy ESPC world. And when I did my MBA at UC San Diego, I thought that I was going to study sustainable agriculture, kind of the business side of sustainable agriculture. That's my passion, food, cooking, gardening, farming, all of that. And when I got there, there was a internship offered over the summer um, through the Milken Institute to talk about sustainable water infrastructure. It was in Israel and I was in California. And so there was this delegation being brought over there from California to learn things from Israel about their water innovation and ways that they've solved for sustainable water infrastructure there. And some of those, they approached it from, I guess, three legs of the stool, from the economics and financial models, from the policies that can facilitate projects, and then from the technology angle. So there's a lot of discussion about things like desalination and leak detection and non-revenue water and fixing pipes and different inventions and technological innovations to allow these things to happen. And then one of the parties from California that was brought over there was an ESCO, and it was to specifically talk about how ESPCs can help public sector agencies to implement some of these innovative technologies as but knowing that a lot of public sector agencies don't have any budget to do these things, but recognize that their infrastructure is aging and they have non-revenue water and just generally are inefficient but can't pay for it. So how can ESPC be a financing vehicle to allow that? So it really opened my eyes. I had never heard of ESPC at that time. And suddenly I was kind of thinking about not as much sustainable agriculture, but about the water that helps to fuel that entire industry and all of the food that we eat, and then the amount of
Mhm.
energy that it takes to provide that water to grow our food. So suddenly I was kind of living in this water, energy, food nexus, and I continue to live in that space. And that's the kind of companies I work with at Trellis Strategy. And over the last couple of years, working with this water, energy, with this campaign. So just to kind of narrow in on that graphic that we saw during the agenda slide, uh, personally, I hadn't thought about how energy is used for water and how much water is used for energy. And as public sector agencies, the kind of projects that you can do that kind of touch on both things. So, energy for water, in order to treat and transport water to where it needs to be requires a lot of pumping. And that's all very, very energy intensive. In San Diego here, the water agency offers a tour of the Colorado River and the Delta. And they take you all the way to Sacramento and all the way to the Colorado River, um, to the source to show how water gets to where it goes through these huge aqueducts going through the fields and all
Mhm.
these huge pumps that take water, the lift water, these lift
Over
stations.
mountain ranges.
It's incredible the way this
Yeah.
water system works. There's so many books on it, and it's really fascinating when you start to see how these things were engineered and the dams that are built and all of that to keep our water. And it's super energy intensive. And then, I'm sure you all know that how much water is used for cooling. And then obviously there's beneficial uses for water like generating hydropower. We'll talk about, kind of narrow this in on ESPC and how you as public sector agencies can actually address the water energy nexus through your energy savings performance contract projects. Um, but we did want to paint a picture of, you know, of this bigger picture, especially like mining resources. When you think about the amount of energy it takes to even extract water, um, and through fracking, that takes so much water. When you start thinking about things like solar and battery storage, it's just way less water intensive. So when you start to think about how energy systems depend on water and how water systems are highly energy intensive, you can really start to understand how water availability can directly impact energy system reliability. And that when you think about saving energy, you're really thinking about saving water and vice versa. Here's some stats. And at your municipal facilities, I've read this stat over and over the years that water systems at municipal facilities, water, wastewater system for treating and transporting water are usually about 30 to 40% of the total use. It's usually the biggest source of
Hmm.
energy use at your municipal facility. Um, Water treatment accounts to anywhere from 1.8 to 5.4% of global electricity demand.
Yeah, that's
Water treatment
massive.
being like reverse osmosis, desalination, harvesting the water in the ocean or, the underground aquifers, desalinating brackish water to make it into drinking water, super energy intensive. Pumping for irrigation accounts for 70 to 90% of energy use just for transporting water and pumping it, like we were saying, up mountains through these lift stations. And irrigation is super, when you're driving down in many states and see all these big open farms and you see this water
Mhm.
irrigating the fields, and you think, oh, there's so much water wasted, especially as Chris and I were talking about earlier, in the middle of the day. You're like, half of that's probably evaporating. You also might not be thinking about how much energy is being wasted, not just water. So there's way more efficient ways of irrigating, like drip irrigation. So we'll talk a little bit about that, but on our last webinar of this campaign, we mostly just we would be remiss to not talk about the water energy nexus as you go about designing and building and just considering what your ESPC might look like. Don't forget about water. Chris, did you want to talk about the cooling towers?
Yeah, so this is a image I've found that everybody's seen things like this before, right? And for most lay people, they can't tell the difference between, smoke and water vapor, right? And everything is smoke to people when they see it coming out of, factories or whatever. And, with these, the short, squat cooling towers you see that are mostly associated with nuclear power plants, that is, billions of gallons of water vapor that gets put up into the atmosphere every year, right? Just like cooling towers on large commercial buildings or schools or whatever. And in dry environments, like where we live, I live in Las Vegas now, moved from the East Coast about 8 years ago. And um, Jamie's from Chicago originally, but lives in San Diego. So we're now both living in the very, very dry Southwest. And you really see the impact here, right? It is amazing. And for most people who really don't understand that, there's an unbelievable amount of water that's absolutely wasted for everywhere from, farming and pumping and, aquifer withdrawals and all that. There's a lot of leaks and everything else. And so anything that we can do through performance contracting for cities, towns, and school districts and state agencies, it all goes back to reducing the amount of power generation that's needed and thus all of that water that's used. Next slide.
So, this has always mattered. There's always been this nexus, but lately all we hear about is the development of these data centers and the amount of water,
Mhm.
and we hear about the amount of energy that's going to take. That translates directly into the amount of water. So this matters really more today than ever with this rapidly rising demand of development. Also, we already talked a lot about food systems. We are a growing population. There are more mouths to feed. Agriculture currently accounts for 70% of global freshwater withdrawals. That's only going to increase. So, being able to do this more efficiently and recognizing the strain on our water and energy resources is really important. And again, we'll soon get to how this actually, is grounded and relates to you as a public sector agency. And then extreme imbalance across the United States. We hear and experience droughts, floods, and there's different things that we can do in each of those conditions regarding our water and energy strategies.
Yeah, and that link that was on the bottom of that slide, really interesting article. Go back and click on that when you get these. It's about data centers. So here in the Southwest, and I've lived in both the Southwest and the Southeast and the Northeast, and it's getting very precarious in what's gone on with the changing climate in these different areas. And this has been in the news recently, right? Especially because of Colorado River Basin, which serves 7 states and 40 million people, 5 million acres of farmland. These rising water costs, and we're in year 26 of this mega drought. And the first time I came to Las Vegas in 2000, the previous year, they had opened the floodgates to bypass water around the Hoover Dam. That's how much water was in Lake Mead. It was up to the very top. Now the lake is at about 33% full. Hasn't been this empty since they were filling it in the 1930s. And it's because of what we see in this graph on the right-hand side. This just came out of an article I read. Winter never came to Colorado. What does it mean for water supplies? All right. So this is a graph that shows like all of the previous years, or the light curves, and then the 1990 to 2020 average is this dotted line. So more recent history, and then this past year, right? The one I think that's red, as of April 7th, it's incredibly low, right? It's never been this low. It's like the lowest snowpack on record. I was reading this article, and there were areas where they used to go down and put like yardsticks into the snow, and there was traces of snow, right? And same in the Sierra. They just did this up near Lake Tahoe a few weeks ago, and it's very similar, um, which is a big problem, right? Because that's where most of the drinking water and irrigation water for the whole Southwest comes from this water basin. So it doesn't bode well for the future. And it's not just for people here, right? It's for people who come to visit and go to, whether it's Disneyland or Las Vegas or wherever. It's going to have a lot of downstream impacts. In the Southeast, those of you who may live, in Florida, Georgia, the Carolinas, all the way across to Texas, um, flooding is becoming more and more common, and very large storms like Hurricane Harvey. Right? Houston is still recovering from Hurricane Harvey all these years later. And in places like Miami, where I lived and went to school my first year of college there, and now they have these king tides, right? On a full moon, the water is coming up out of the storm drains, right? It's amazing. It's just going in the opposite direction of the way it's supposed to go. So, and this isn't getting any better anytime soon. So anything we can do to help this, I think, is going to be very, very important. So now we get to how ESPC can help. So we all see the problem, right? Their water systems are some of the largest energy users in most facilities. As Jamie said earlier, right? Water and water treatment plants are 30 to 40% of most towns' energy use. A lot of these places are old, right? I lived in New England for decades, and some of these water treatment plants were almost 100 years old, right? And wastewater treatment plants were the same age, and they would have to basically rebuild them every 20 to 30 years, right? So they're very expensive to build and very expensive to maintain. And there's efficient HVAC, cooling tower optimization, low flow retrofits. A lot of the stuff have been in many performance contracts over the years, but these days there are even more and more technologies out there, and they've improved these technologies to be able to reduce the energy use in these buildings even more. What we're also starting to see a lot more of now is looking at water loss, leaks, and meters that aren't working. So cities and towns are basically hiring ESCOs to go in and redo the whole revenue generation portion of their water systems. And it's been a big improvement for many places, right? The water losses and the leaks sometimes are truly staggering. And in some cases, 25 to 60% water savings and 15 to 30% energy savings. Another huge opportunity that's often not utilized is capturing biogas to use combined heat and power systems, sometimes called biodigesters. And one of the projects we'll talk about in a few minutes, they've done this and created 10 megawatts of power generation at a water treatment plant, right? So this is huge. And otherwise, it just gets wasted. A lot of it just gets flared off. Same with landfills. So these things are linked, right? Water and energy savings are directly linked, creating a lot of opportunities for bundling these projects. Next slide. So as I mentioned earlier, measurement verification, or M&V, is really the cornerstone of success of these projects. And for many years, a lot of the main protocols did not include water. right? Like IPMVP, FEMP guidelines didn't include water when they first came out. I was lucky enough to be involved. I think this is almost 10 years ago with Pacific Northwest National Labs and the Nevada Energy Office, and ESCO and a few other folks, along with Western Resource Advocates, to create a water measurement verification protocol that then got adopted pretty much nationally. And they've worked them into IPMVP, right? That's the International Performance Measurement Verification Protocols, and that's a link to that, run by the Efficiency Evaluation Organization. That's really the global gold standard for performance contracting as well as utility demand side management programs. Usually option A, retrofit isolation, which is making like a one-time measurement, or option B is using continuous measurement like water meters, are typically the two methods that are used. FEMP MNB guidelines, this is what's used for federal performance contracts. They are the gold standard for federal projects. They're really set up for federal agencies, but they do provide a tremendous amount of guidance, right? Like EVO just came out with a guidance document, which you can find when you go to that link, for owners. But FEMP has been doing this for years and providing a lot of guidance around MNV for performance contracts. And then there's these water meter projects. Like I said earlier, they can be super helpful, right? But there's been problems with a few of them where a very, very aggressive take on the savings has caused problems and a few lawsuits. And we need to be very careful when you do this, when the owner is working with the ESCO, to not be overly aggressive in the expected cost reductions, right? Because if you're looking to increase revenue, right, that town or that city is literally banking on that revenue. So you have to be very careful that it's not too rosy an estimation of what that revenue increase is going to be. And all of this together really allows a tremendous amount of bundling, right? Because some of these water measures, depending on where you are, if you're in Boston or California or places that have really high water costs, even here in Las Vegas, when I started working here 20 years ago, water was 1 to 5% of utility costs for most big entities, the casinos and hotels. Now it's 20 to 25%, right? It's a huge difference. So these water conservation improvements can either help pay for things or other measures can help pay for them. Next slide.
And yeah, I was just going to
Yeah, go
say,
ahead.
here there's this, I guess, conversion, this statistic we found where 25 to 60% water savings translates into 50 to 30% energy savings. While not every water savings measure might be easily attributable to the corresponding energy savings, but you still want to implement the water savings, knowing that you will, or the water measures, knowing that it will lead to savings, even if not like able to be calculated, measured, and verified. The nature of an ESPC as a bundled project still allows you to implement those water infrastructure improvements. Um, in some way you could think of it as paid for through like the lighting retrofit you do, right? Or the solar
Mhm.
panels that you put up, and all the energy savings that you can glean from those measures can pay for things that might not have an attributable energy savings part of the project. You'll probably still see it. It just might not be included in your pro forma, but you're still able to implement that as part of the project in most cases, bundled through that bigger
Yeah,
project.
yeah. And there's sometimes intangibles like that become community benefits.
Yeah.
In the utility demand side management industry, they're called externalities. So that, every kilowatt hour you reduce, a lot of ESCOs do a great job of showing this in their proposals and their investment grade audits. This many cars being taken off the roads, trees being planted and all that. You can add to that list. This is how many gallons of water are saved at the power plants, depending on the mix in that state, right? You can go to eGrid, all right? It's this free website and figure out what the utility mix and how much water is used per kilowatt hour delivered.
Yeah.
So we're going to give some examples of things that can be done. These are water conservation measures. If you're a K through 12 school or in higher ed that has a lot of sports fields and so on, irrigation controls for athletic fields are an unbelievable source of savings, right? Um, you, you all see this, driving to work in the morning, you drive by a high school and the water is just gushing everywhere and it's flooding down into the parking lots from sprinkler systems, right? And this happens everywhere. It's not one place or another. Huge opportunity, especially places that have very different seasons, wet seasons, dry seasons. Putting in smart controls, we'll talk about this in a few minutes, really makes a huge difference. And just low flow fixtures and plumbing upgrades that have been around for years, waterless urinals, leak detection,
Yeah,
HVAC
you don't want to
optimization.
irrigate during a rainstorm or the next day.
No, and I have seen it. I used to
Yeah.
see it back in New England all the time. Um, HVAC optimization has really come a long way. There's now technologies out there that use almost no water in HVAC, which is truly amazing. Um, and these projects can bundle the water and energy upgrades into one project, like we mentioned before. That can make a huge difference to a school system or a university, especially state universities that don't get the funding that private universities do, to get things that will just get pushed off to next year, right? And get it done as part of this performance contract. And you can also scale these things across campuses, right? You can take a high school, say in a K through 12 environment, which use, because of the much larger real estate, use a lot more energy, help the energy savings at the high school to pay for things that are in the elementary school, right? And so on and so forth. Same with cities, towns, a water treatment plant savings can pay for stuff at the library.
Mhm.
If you're a city or county, this advanced metering we talked about is really amazing because it's the water conservation companies can find the leaks and get them repaired, but also by upgrading all the metering and going from actual physical meter readings to AMI, right? Automatic meter reading. Instead of somebody literally walking up to the side of your house, they drive down the street in a truck and it picks up the meter readings, right? And these days, it's probably just all done over the cell networks. There's a lot of opportunities there. Same with pumping optimization. Like every water system and wastewater system in this country is designed for the peak day, right? And you'll hear me talk about this later on for Los Angeles County, 500 million gallons a day, right? And then that's all the pumps and the piping and the size of the valves and all set for that one worst day. And that's for the future day, right? These things get designed 30 years ahead of time, knowing that there's going to be growth in the community. So sometimes these 1,000 horsepower motors, and I've stood next to these, are running at full speed, right? Pumping a third of the water that's needed, right? And they end up putting these pressure reducing valves after them, which just takes all of the thrust out of those pumps away and just dissolves it. So putting in a variable frequency drive saves so much energy. It's unbelievable, and also increases the lifetime of all of the equipment. It reduces corrosion inside the pipes and so on. So there's this weather-based EPA WaterSense label. It's sort of like Energy Star label for water. It's exactly what EPA WaterSense is. You see it when you go to Home Depot or Lowe's on the toilets now, and most of them have this EPA WaterSense label. There's these smart irrigation controls, and that's a live link to this EPA WaterSense website. These things are amazing, especially now they're all AI assisted and all that, and it saves 50 to 70% sometimes on water usage. It's amazing. Really take a look at that. And the wastewater treatment plant upgrades, like I've mentioned, are incredible. So for University of Hospital, optimizing cooling towers. This is an incredible opportunity. I've been working in this for years, and I've seen cooling towers that waste probably 30 to 50% of the water just because of the way they were designed. They're not always maintained as well as they could be. Um, and the controls, usually they're out in the weather all the time. If you're up in the northern parts of the country, these are all sitting out on rooftops and are covered in snow and ice and this and that. And they often really suffer over time. Uh, Central plant upgrades, same thing. There's a huge amount of waste, especially in older central plants. Um, and water reuse opportunities. I see this all over the place where a lot of water that just gets sent to the drain in boiler systems can be reused to heat the water going back into boiler systems, called condenser water reuse. Um, So there's huge potential for this. And EPA actually put out a whole water saving tips guideline for hospitals. And that's a live link. When you get this, you can look at that. There's also opportunities in the process side and autoclaves and steam and sterilization in hospitals as well. All right, I can go back to this. So water or wastewater, again, because this is where the largest amount of energy is used, and you can tell just by looking at this picture here, these are aeration pools where those arms are getting spun around, right, mixing up these tanks with huge motors, and they have, 300, 500, 1,000 horsepower pumps that are inside these buildings, controlling all of the water that gets moved around these sites. So it makes for an amazing opportunity to reduce the energy use and also upgrade these systems, which run, every day, every year for sometimes 20, 30, 40, 50 years. Upgrading pumps and air compressors, which are often overlooked, which have a lot to do. And a lot of these systems, they power blowers and others. And the motors, which again are often oversized. And sometimes when they fail, they get rewound, which is much cheaper than replacement, but they reduce their energy efficiency by 10% each time they're rewound. And a lot of controls. Again, you can go into some of these control rooms and you can tell they were designed and built in the 1970s. Look like something out of old science fiction movies. And now you can replace them with, screens and all digital controls. And that alone will save 10 or 15%. Optimizing the aeration systems is huge. When fine bubble diffusion came out about 30 years ago, it was a revolution in water treatment. It really reduced energy use by 30, 40%, just that measure alone on a lot of the water treatment systems we used to work on. And fixing leaks and reducing non-revenue water is massive. Even inside plants, there's a lot of leaks that just don't get attended to. And the biogas, as I mentioned, that is a massive opportunity. Next slide. So DOE put out a guide for this as well. Again, I didn't know this until I was doing the research for this webinar. And this was just published in March of 2018, so all the information is pretty new. And I took a quote right out of it. In recent years, a growing number of utilities responsible for cleaning wastewater have been moving from a strict focus on wastewater treatment to an integrated focus on water resource management, which is a fabulous, fabulous idea. Some formally renaming themselves water resource recovery facilities. And we're seeing more and more of this in this country. This gets done a lot in other places. I was very lucky with the Association of Energy Engineers. I taught a course in Singapore about 15 years ago. The water treatment there in Singapore it's like a city, where the country is basically a city. And their water treatment facility had been creating bottled water from treated wastewater, right? That's the situation they're in, right? And there was a lot of jokes about it, but it's real, right? And this is happening around the world. And having a more integrated focus is improving economics and improving delivery to the communities. So this study had showed and again, it's even greater now. These are pre-pandemic numbers, keep in mind, right? Those numbers are probably 25% higher by now, right? They were looking at 271 billion over the next 25 years. And because very few of these agencies have any cash left, right? Especially after the pandemic, even after this Great Recession 15 years ago, there was not enough capital being brought in tax dollars to put in for capital upgrades into a lot of these facilities, right? And because of the economy being so bad, it was very hard to get referendums passed in communities to spend 50 million or 100 million to upgrade water treatment plants. So they just kept using the band-aids, right? Duct tape and baling wire, as we say. And now it's become crises, right? All over the country. And I found this great graphic in here. And this is looking at life cycle costs. What are the costs of doing nothing, right? So if you look at this funding available today, and almost none of these have a lot of cash laying around, right? So it's a medium cost on a life cycle basis to do it with funding you have today. If you finance it through a performance contract, yes, it's going to be a little more expensive, right? But you're avoiding opportunity costs, which is what we see when you go to delaying the funding, right? And this is, probably not quite 50% more but it could be 5 years, 10 years before that happens, right? And things just keep getting more and more expensive. And if you don't do anything, right, which is the answer a lot of the times, and it's often because of politics and other things, no action taken, it's almost off the charts because what ends up happening is emergency replacements of large pieces of equipment that failed during the worst time. Like we
Mhm.
saw in so many states now during these storms dropping 10 and 12 inches of rain overnight, right? And sometimes multiple inches per hour for days at a time, absolutely overwhelmed stormwater systems, right? And it was basically blowing out pumping systems and taking out bridges and all these kinds of things. So there's opportunities to do this today through performance contracting. Next slide. Right. So we probably already talked about most of this, but financially, these cost savings really can make a huge improvement, not just to financial systems today, but you're creating a hedge. And as we see, right, gas prices have gone up by 40%. Electricity prices are already up 30 to 40% in the past few years. They're going to go up again over the next few years. It was already going to happen because of, data centers and all the stuff and smart grid and having to basically weatherproof a lot of the distribution systems. Now the natural gas costs that almost half the energy in this country is produced with is going to go through the roof over the next few years. Same thing with environmental, right? Helping address the water energy nexus through performance contracting reduces greenhouse emissions. Water conservation can help that water be used elsewhere in the community and improve system efficiency and enhances long-term resource sustainability. So you're creating a hedge not only financially, but environmentally and for your community through having these resources available to you. And operationally, it just makes these systems more reliable over time and reduces maintenance needs. A lot of the projects I've worked on over the years, you're taking a 30 and 40-year-old pieces of equipment and putting in brand new things and getting your ESCO either to do the maintenance themselves or working together with the owner, and the ESCO trains, say, a new company they can hire to do this, and it gets paid for by the savings over time. Really, it's a fabulous way to do this and really increasing the resilience of everything over time. Next slide. Right, I'm going to go through these case studies really quick. We're running out of time here. So, LA County Sanitation District is one of the largest water treatment organizations in this country and almost in the world. I was lucky enough to work with them. Unfortunately, it was through the pandemic. We started in 2017 through about 2022. Um, but they started doing energy savings projects many years ago, and they have a huge engineering section. What they were finding that there were things they know they needed to do that were process optimization and things that just needed to get replaced. They couldn't get the money fast enough or the workflow done fast enough with the staff that they had, right? So they started looking at performance contracting. I got referred to them, went and talked to them. We got an RFP out on the street, and bang, they started doing these performance contracts and realized they could get the projects done in half the time they could if they did it. Just like that graph I showed you a few minutes ago, they decided they were going to use, in this case, they're using their own funding that they would normally use for this, capital appropriations. So it's really the best of both worlds. They're getting the benefits of a performance contract without having to pay the interest on by borrowing the money. So two of these are already complete. This JWP plant, which is one of the largest plants in the U.S., and the Valencia plant, which for people who are down there, it's right next to Magic Mountain. Um, and then they're doing these next two are just getting started now, are going to be finished in 2027. And for this, it's not about saving energy as much as it was replacing equipment that needed to be replaced. But the bounty of it is getting all these energy savings, right? And these cost savings. Then they can then use that money for other things inside that system. And that system has really been tested the past 5 years. Everyone's heard of these atmospheric rivers that are hitting Southern California, absolutely swamping the wastewater system. So this has been a huge help to them. Next slide. Colorado has been doing a lot of this, right? One of the country's leaders in this. This is a great statewide project, Department of Human Services. $29 million. They use smart irrigation controls and low flow domestic fixtures, as well as, lighting and solar, all the other things you'd expect, and reduced the water use by 28%. So imagine that now that, Colorado has seen this terrible winter with almost no precipitation, and what they did get was in rain, which can't be collected, right? And there's a great quote in that study I mentioned earlier. Snowpack is like long-term water storage devices. They're like ice storage, right? Sitting on the tops of mountains that it's gravity fed. Almost no energy is used, right? It's free from the sun and free from gravity to be able to use this water. So, and us having to replace that using energy is very, very expensive. So this really reduced utility costs, improved system performance, and addressed deferred maintenance across all the facilities, right? Like I spoke about, they were able to replace old things with new things that don't need nearly as much maintenance.